So here is the new method. This is called the freeze and slack method. I'll just show you 2 examples. Then you will see that you can apply it for many more examples. Okay, let us start. So I'm going to pretend like this is a good pulley. Okay, and if I lift this up, that goes down. Right? Now the same thing I want you to imagine what happens. I freeze this entire system. Nothing is allowed to move. Nothing can move without my permission. I freeze it and I lift this block up. What is going to happen? So when this guy goes up by A, now goes up by A, acceleration or displacement, we don't care. Okay, this guy goes up by A. So here is my pulley. Okay, so let us assume that this was the rope. If now I lift this up by A, or let's actually ignore that side. Let us concentrate on just one side, this side. So if you lift this object up by A, what does it do here? It creates a slack. How much slack? How much slack? Well, if you went up by A, it should create a slack of A. So I have a slack here which is A. Because the rope no longer looks like this, it looks like this. And what you can do is, once you have a slack, you can always make this slack, see that is the part which is actually the slack. Okay, the rest of it is straight, taut. That extra bit is equal to how much this guy went up in terms of size, in terms of the length. So what I will do is I will basically say this is a straight rope with a extra bit like that, which is A. Now this is A. We'll call that slack A. Now once I have lifted it, I am not lifting it and showing it to you here, but you can imagine the idea. Once I lift it, there is a slack A. It's going to just remain here, nothing is going to happen because everything is frozen. I'm going to move the slack from this side to that side because I can move it across a pulley. And if I did that, this A is gone here, and instead what happens? You get a slack of A there. How do I get rid of this slack? Pull this fellow down by A. So when I pull this down by A, this slack goes away. We could have done this by saying, I have moved this from here to there, this was the slack, etc. But I think it's easy enough to imagine even without the movement. Okay. Now let us take this case and we will see why it is twice. But before we get to why that is twice, I want you to first think about what happens for different types of situations. Let us think. When I moved this up, you got a slack of A. Why? Because there was one rope connected, and that one rope, as you lift this up, this point is fixed, this point goes up, there is a in-between part extra which is A. Now what will happen if I had a block that was connected to 3 ropes? Let's not worry about where it goes for now. Let's assume that wherever it is fixed. Now if I lift this block up, how much slack will I have? Let us say I go up with A. You will have 3A? You will have A? You will have A on this rope, A on that rope, A on that rope. You don't have 3A. You don't have 3A. You have A. Okay. Now, let us take another example. Let us say I have a block which has a rope with a slack, and this side again I have a rope with a slack. Now instead of marking it like this, what I will do is I will mark 2 ropes, and in all these cases we are going to assume that you can't tilt this and things like that. They are all particles. If I make the ropes very close, you can see that they can't be tilted. So we'll assume that they are all particles, but if they are so close, you can't see them. So we'll make them look little larger. Now this fellow has a slack, that fellow has a slack. Let us say that this fellow has a slack of 2 meters and that fellow has a slack of, let us say, 3 meters. Okay. How much can I pull this rope down by?
2 meters.
Why not 3 meters? It can't go more than 2. Why? Because when I pull this down by 2, this fellow's slack of 2 is gone. So lifting it up produces slack. Bringing it down destroys slack. Actually, I shouldn't be saying lifting it up. It could also be lifting it up could destroy slack. It depends on how the object is and how the rope is. In this case, lifting it up produces slack. Bringing it down destroys slack. If the object was like that and the rope was hanging down, it's exactly the reverse. But basically you know that if I did this motion, it produced slack. This motion destroys slack. Right? So now, this is 2 meters, that is 3 meters. If I pull this down, the 2 meters is gone. But what happens to this side? 1 meter slack is still there. So can I make this fellow such a way, can I pull this down in such a way both ropes are taut? Not possible. No slanting allowed because these are all particles. So it's a tiny object. So you can't really tilt it. So think of it like this. Now you can't do any slanting here. Not much scope for slanting. So now tell me, is it possible? So when is it possible? Then when you pull an object down, all the ropes above basically become taut. If they had equal amounts, if this was 2 and 2 or 3 and 3, you could have pulled this down and made sure both are equal. So if I want a rope, if I want an object with slack A and slack B to go down and make sure that these two are exactly taut, what is the condition? A has to be equal to B. So that is clear. Now I can't do that for such a problem. I can't take this slack and move it there. But I can, not for this object, but for another object. And that object is a pulley. Because with a pulley, slacks can move around. So if I had a pulley, and on this side I had, let us say, a slack of A, and on that side I had a slack of B. Let's put numbers here. Let us say that this was 2 and that was 3 like before, and I want to pull this pulley down. You can move a pulley in 2 ways. You could keep this object and you can move this pulley by grabbing this end, both these sides, and lift it up like that. You have a slack. Okay, but suppose one side had more slack. So let me construct it like that. Now one side has more slack. Now it looks like one side is 2 and one side is 3. If I pull this down, look at what has happened. This side has become taut. This side is still lot of slack, right? It's hanging around like that. So what do I do then? So now they are unequal slacks. That's why one is taut and one still has some slack. But actually if it is a good pulley, all I have to do is to let it go and pull it down like this. And you will find that you can pull it down. How did I manage that? So let us say it was unequal slacks like this. Now it's unequal slacks, right? Unequal slacks. Correct or no? Yes. Now if I basically decide to pull this down, okay, this looks a little bit fishy. So let us turn this around, then you will see the difference. Now it's the same thing. They are unequal slacks and this doesn't fall off. But as I pull this up, can you see that the slack from one side is moving to the other side? So that's what a pulley can do. So let us see the same situation in reverse. If I saw this in reverse, as I move this pulley up, the slack is moving from this side to that side. So in a pulley, you can get the slacks to become equal. But in our minds, we can redo this in a different way. We can say they have to be equal and you can pull this down. Instead of saying that as I am pulling the pulley down, they become equal, I can say first I will make it equal, then I will pull it down. If I make this equal, how much of this slack should I move around? 1.5? 0.5. So I will cut this slack up a little bit. I can say let's make this 3 into 2.5. And then little bit slack which is 0.5, let's move it around there, and what happens to that slack? 2.5. And now if I pull this down, 2.5. How much will this be pulled down by? 2.5. Because when this guy goes down 2.5 is destroyed. Remember, when I pulled up this block, the block went up. If you take this block, the block goes up by A. Each rope gets A. Block only goes up A. Similarly, when the block goes down A, each rope loses A. Pulley goes down 2.5, each rope loses 2.5. Pulley goes up 2.5, each rope gets 2.5. That is easy to imagine. Correct? So, for any time you have a pulley, let us take a pulley like this, and let us say that I had two blocks, and this block moved up A, this block moved up B. How much can the pulley move up? If this moves up A and this moves up B, how much slack will it create? A. How much slack will this create? B. Okay. So now what do I do? But they are not equal. No problem. First take the B there. How much is the total slack? A plus B. Cut it into half. A plus B by 2. A plus B by 2. So you put a slack of A plus B by 2. A plus B by 2. Now this pulley can be lifted up by, because I can just grab the sides of the pulley and lift it up by A plus B by 2. No more movement, because the movement has happened before. Obviously, in any real problem, the movement will happen concurrently, together. So for example, if I look at a question where this is going up, that will come down, and the pulley may also go up. Look at this. Pulley is going up, block is also going up. But it is very messy to think through. So do it step by step. So when you say that the rope is actually moving over the pulley like this, don't do that. You just say first part, rope is moving, pulley is not moving. Second part, rope is not moving, pulley is moving. Easy to think. Okay, and that's all we are going to use now. Very simple. Let us use that. You will see this with pulleys all the time. So let us see this. Freeze. Nothing moves. Lift this up. How much? A. It produces a slack. How much slack? A. How do I get rid of this slack? By holding this pulley, grabbing these two ends and lifting it up by A. So if I lift this up by A, this is gone. But when the pulley goes up by A, it produces a slack A, slack A. Okay? Now I can't do anything about that end, it's already fixed. So take this slack and join it. How much? 2A. So when I bring this fellow there, this is gone. And nothing moves without my permission. Okay? Now I have got 2A. Okay? Take that 2A and bring it here. This is gone and you are left with 2A. Now to get rid of this fellow, what do I need to do? Pull this down by 2A. Finished. Everybody followed? The pulley movement, remember, destroyed an A here, but produced AA. Don't think of it as it produced 2A. It produced AA. In the unique case of a pulley, that AA can slide around. But if I took a block and moved it up, it will produce AA and it can't slide around. Ropes can't just go around a block like that. They may even be different ropes. But in a pulley case, this A that it was produced on that side can go there. So when the pulley moves up, it destroys A and it produces AA. How many slacks will you produce? As many ropes are connected. That's it. Sometimes you may find pulleys are connected to 3 ropes. How is it possible? You can have a rope connecting that, no? So when you grab this and lift it up, there will be a slack there. Now this slack can slide around, but that slack, but it may be connected somewhere else. For example, Archimedes' famous pulleys were all connected like that and connected like this and connected like that. Is this one rope? Yes. And then there is a block here. Very tricky. No? Looks tricky. So if I lift this block up, that means it creates a slack A. But if this creates a slack A, grab it and lift it up. What happens? It produces A. But this A can be moved around to this side, 2A, 3A. I don't know what to do with it. Okay, so we will simplify the matter by allowing this guy to go around like that. So now let's redo this question. A, do it step by step. Okay, because then you will see that actually it works every time. A, what is this? What is the symbol for? Slack. I am going to be lazy. I won't even draw that because then I have to draw it. I have to cancel it out. So now I am going to just tell you. You can just tell me the answer. A. This is a slack. I mean, I don't have to say slack. If I show you the slack, that is A. Okay, let's grab this and move this up. How much? A. Take this one and move it there. 2A. 3A. 3A. Easy? Definitely easier than saying x1, x2, right? So we will see that this starts to work very well in many problems, but I hope this idea is clear to you. Just as a proof that it actually does work, it is useful to do a small demonstration and check it out. Okay, so can somebody help me out? Come. One of you just come. Come on. So let us take this. What I would like you to do is I'll hold this pulley there. It's okay. She just has to hold this part. So right now, what I would like you to do is bring this closer. Okay. So now you can see that the starting level is this. Okay. Now what we are going to do is to make this object or make her release it up to this point. So can we just use this as a scale. I want you to release it till here. Okay, so you can see that when she lifts this up so that this bottom comes there, then right now I am going to hold the rope. So can you just lift it up? What has happened now is there is a slack. I can grab this and I can move the slack there. Now where is the slack? So what we have done is exactly move the slack from that side to this side. Now if I let it go, it has come down to this level. which will be almost like the duster. Well, this is an experiment which is being done with not too much of care for accuracy. Okay, but it's broadly accurate. That was the level of the pulley. So now let us bring it back. Can you bring this slowly back? Yes, that's actually what happens, right? So when the pulley is there, these objects are at this location. This fellow goes down by A, that goes up by A. Now what we are going to do is to ask her to remain where she is, but we will have the pulley come down by A. Can you actually hold this there so I can? I know it's a little tough, but okay. So this is A, that is A. Now what we are going to do is to make the pulley come down by A. Ready? Now if we keep these two fellows where they are, just hold them there. When it comes down, you have a slack on both sides. How much? A, A. Now I can move the slack to this side. Now this fellow has a slack of 2A. Now you should keep this at the same location. Okay. So this is 2A. Now release that. Now you can see that this guy has gone down. That has not gone down. But this fellow is the motion of the pulley. A. Whereas this has moved A plus A, 2A. Now what do you think would have happened if in addition to the pulley going down A, she went up A? What will happen? Well, pulley has now come down A. Now she goes up A. This will go down by further A. So how much will this guy go down? 3A. So if pulley is moving and one of the sides is moving, the other side you can calculate quite straightforwardly, right? What if she goes up B and the pulley comes down A? Think. A plus B? 2A plus B. So what would that look like? That would look like this object, and I have this object going up B and the pulley going down. What does that mean? Pulley going down A. What kind of problem will have a pulley going down A? Connected to an elastic object. Actually all you have to do is to put this inside a lift. Lift goes down with A, pulley is going down with A. Very common problem. Now if the pulley goes down A, slack A, this goes up B, slack B, B, 2A plus B. But you just saw that here. When there was a pulley fixed here, this object is fixed, this goes down 2A. But if this also goes up, then 2A plus that. That's exactly this problem. Is that clear to everybody? Okay, thank you. Do you have that? This is a pulley, that pulley can also move. So directly if you see it, it's all going to happen in a fraction of a second. But all the calculations obviously are not going to take fraction of a second. So let us do it now like this. Okay, so I need one other volunteer. Can you hold this? Come. Hold this. Just grab that. So when I say release, you can release it. Just grab it. Keep it down. Keep it down. No, just hold it. Yeah. Hold that and hold it there. Yes. Okay. Good. Okay. Shh. Quiet. So when I say release, because it's going to get over very quickly. Ready, steady, go. Okay. So this one moved up, but overall did it move up or down? Overall it moved down. So it's very hard to figure out directly just by looking at it and looking at a small part. Because what you'll have to do is you'll have to add this guy's motion, this brown pulley's motion, and then Also look at the fact that relative to the brown pulley this is going up. So you'll have to combine all of those things together because the whole thing happens quite quickly. So what you have learnt now is to actually do that kind of calculation using slack. Yes.